All right, guys, so let's do part 2. So technically like example 3 here, we are going to try a bearings problem, okay? Bearing problem with using law of cosines. So make sure you pause me right here, write this problem down before we begin. Okay, so we have two trains that leave the station in different directions. Train A travels northeast 32 at a speed of 47 miles per hour. Train B travels northwest 21 at a speed of 52 miles per hour. How far apart are the two trains after 3 hours? Okay, that's our first question. How far apart are they? So again, first thing is a diagram. So we are going two different directions. We got train A's direction. So let's just say I start right here. That's their station. Move it actually a little over. Okay. If you want, put like a little S so you know that's for station. Train A is going northeast, so that should go roughly something like that. And I'm going to label that as A so I know. And then B is going northwest at 21, okay? The directions that they gave us were in bearings. So bearings, remember, have to come from a pole. So right away from the station, I'm going to draw in these poles. All right, so now I'm going to draw in the degrees. The northeast one was a 32, and the other northwest was a 21. Now look at this, right? 21, it looks gross that I can't really fit it in there. This happens, guys. So redraw it a little bit so you have some room in there. There. 21. Okay, so we have that. And I want to know how far apart are they. So right there, I'm going to put an X. I don't know how far apart they are. Okay, so that's done with. But now they told me how fast they were driving, right? 47 miles per hour and 52 for the other one. The two trains traveled, though, for 3 hours. There's a reason why I'm telling you this, right? It's to figure out how far they actually got. So if A was traveling 47 for its speed per hour, 47 times 3, they went 141 miles. Okay, I'm going to put my units on there right away. And then B speed was 52, and for the same amount of time, so 156 miles. All right, I'm going to check my diagram. Does it make sense? Segment B, the line all the way, should be a little bit longer. It is, so I'm happy about that. If yours isn't, then redraw it, okay? All right, so we got to figure out how far apart the X side. Well, I'm going to kind of clean this up first. I'm going to figure out 21 plus 32, what is that, a 53 degrees? And it looks to me that I have a side angle side, and using part 1 notes, I know I'm going to use law of cosine. So I'm starting with the side I want to know, which is X. Square the other two sides. So 156 squared plus 141 squared minus 2 of the same sides, 156, 141, cosine of the only angle, which was 53. So plugging this into my calculator, taking the square root, make sure you're in degrees, should be getting 133.20 miles in this one. All right, so I'm just going to go in, plug that into my diagram so I know my answer. Awesome. Okay, let's extend this question. Part B, we'll just say, is I want to know what is the bearing from train B to train A. All right. So I want to know the bearing from train B. That's where I want to draw in that bearing. If I draw in that bearing, I'm going to draw out the poles and the green one. Coming from the north, right, or the south. I'm going to draw it a little bit better. Okay. So starting at B, right? It says it right here. And I want to know what line connects the B and the A. Great, so that's this guy. So I need to figure out if I'm coming from the North Pole or the South Pole. We are going to be coming from the South Pole because the South Pole to here is a lot smaller than going this way. Because that way you have to cross 90 plus a little, right? Remember, bearings have to be less than 90 acute angles. So our goal is to figure all of this out. Okay, so we have like two parts of this. We have this little angle on the outside, which I'll color it in orange, and then light blue, the actual angle in the triangle. So it looks like at the end we're gonna have to just add these two together, but we have to first figure out like each part of them. So I'm thinking we figure out the light blue part. To figure out the light blue part, can't I use law of sine because I have a side with its corresponding angle, right? So I can do the setup for the light blue part to be sine of 53 over 133.20, what we just found, over sine of B over, what was it, 141 miles. Okay. So we cross multiply this. Make sure you try this one out. So 141. Hopefully you're plugging this into your calculator by now. Dividing both sides by 133.20. And then you're going to take the inverse of all of that. And we should be getting angle B to be about 57.72 degrees. Okay, so we have that guy. I'm going to plug that guy back in, 57.72. Take that dot away now. 57.72. Okay, good. The only issue now is that orange dot. Like, what law of cosine, law of, sine do I use to figure out an angle that's not even inside of the triangle? No. Some people are thinking maybe we'll take it away from 90. Well, that would work, but there's like a little slice in the purple now that I'm showing, so I can't really take it away from 90. Okay, so that means there's something in this triangle that is going to help you out already. And the spot that's going to help you is this guy right here. Okay, those two are alternate interior angles, so they are equal to each other, so that means this is a 21. So to figure out the entire pink, we're just going to add the 21 plus the 57.72 to figure out the bearing. So bearings have to start Remember, from the north or the south. So this one we said is starting from the south, and we're going to add 21 plus 57.72 to get our degree of 78.72 degrees, less than 90. Great. And we went in the direction to the right, so that is going to be the east. And that is our final answer for that question. All right, guys, good job. Keep up the great work. Keep asking these awesome questions. Keep advocating for yourself. I'm beyond proud of you.